In this video, we're going to be talking about mixtures and separation techniques. Now, a mixture is a substance which contains two or more constituents that can be separated by physical method. Example of a mixture, we have dye. Now, dye is a mixture of several colors, and to separate the mixture of dye into its constituents, we employ physical method such as the paper chromatography. We also have crude oil. Crude oil is a mixture of different substances. In crude oil, we have petrol, we have kerosene, we have diesel, we have bitumen, etc. Now, to separate this mixture of crude oil into its constituents, we make use of the fractional distillation. It's a physical method of separating mixture. We also have the seawater. Seawater is a mixture of salt and water basically. It's also known as salt water. To separate it into its constituents, we also employ physical methods. Example in this case, we'll be using the evaporation to dryness. So a mixture is basically any substance in which the constituents can be separated by physical method. Any substance whose constituents can be separated by physical method is called a mixture. Now, the physical methods involved in breaking down mixtures into their individual constituents are known as separation techniques. So, separation techniques and mixtures they go hand in hand. We'll talk about mixtures, two or more constituents combined together and can be separated by physical method. Separation techniques, the physical method involved in breaking down these mixtures. All right, the physical methods involved in breaking down these mixtures into their constituents is what we call the separation techniques. Now we are going to be looking at different separation techniques. There's different physical methods employed to separate different mixtures. Now, number one here we have the filtration. Filtration is a method that involves the use of a filter paper. All right, it is used to separate insoluble particles from a liquid. Insoluble particles are simply particles that did not dissolve, all right, or particles that do not dissolve in the liquid. Insoluble particles from a liquid. Example, we have a suspension of chalk particles in water and then a mixture of sand and water. So whenever we have a mixture of insoluble particles in a liquid, we make use of the method of what? Filtration. And this is a diagram showing the filtration separation technique. We have the glass funnel, we have our filter paper. All right, we insert the filter paper into the glass funnel and then we pour in our mixture. As you pour in your mixture, you discover that some constituents will be trapped in the filter paper, whereas some of them will move through. The ones that are trapped in the filter paper are known as the solid residue. In this case, let's say we have a mixture of chalk particles in water. The chalk particles will be trapped in the filter paper. It is also known as a solid residue. All right, and then the filtrate will move through the filter paper and it will find itself in the container or beaker, as the case may be. So the one that moves through the filter paper into the container is what we call the filtrate. And then the one that is trapped in the filter paper is what we call the solid residue. In filtration, we always have a filtrate and then the residue, the one that will be trapped in the filter paper is a solid residue, and then the one that will move into the container is known as the filtrate. Now for these two mixtures, a suspension of chalk particles in water and a mixture of sand and water, you will discover that the chalk particles do not dissolve in water. Sand also does not dissolve in water. So whenever we have a case whereby we have a substance, an insoluble particle in a liquid, we use filtration. All right, if it's an insoluble particle in a liquid, filtration separation technique is employed. Here we have chalk particles in water, mixture of sand and water. Chalk particles do not dissolve in water, sand do not dissolve in water, hence we make use of filtration separation technique. Now filtration is also applied in water purification plants and breweries to remove solid particles from liquids. All right, so this is another case where we apply filtration separation technique. Now, number two here we have decantation. Now, decantation is also a separation technique. That is a quick method of separating a solid liquid mixture. Just like filtration, decantation also involves a solid liquid mixture, all right, that has been allowed to stand for some time. That's to say, in decantation, we also have an insoluble solid in a liquid. All right. Remember, filtration involves an insoluble solid and a liquid. Decantation also involves an insoluble solid and a liquid. Just that is a quick method of separating. All right. We have here solid liquid mixtures that has been allowed to stand for some time. Now, the solid component settles at the bottom. Remember, it does not dissolve. All right. It's an insoluble solid in a liquid. The solid component settles at the bottom of the container, while the liquid forms an upper layer. Now, with the aid of a glass rod, you can see it here on the diagram, all right, the liquid upper layer is carefully poured out into a second container. Another word for that is decanted, all right. The liquid upper layer is carefully poured out into another container, leaving behind the solid component. Now, this method, though less accurate, is alternative to filtration. So decantation is just like an alternative method for filtration, just that in decantation, our result is going to be less accurate compared to filtration. All right, decantation is also applicable wherever we have filtration, whenever we have, and that is whenever we have an insoluble solid in a liquid. All right, now we have here what we call sediment. Now, the sediment is simply the solid component that settles at the bottom of the container. You can see it here on the diagram. All right, we have a mixture. In this case, you can see maybe a mixture of sand and water. We allow the sand to settle at the bottom of the container first, and then we carefully pour the liquid upper layer, which in this case may be water, all right, into another container. So the sand that settles at the bottom is what we call the what? The sediment. All right. So decantation can be employed wherever we have filtration, just that it's a less accurate method compared to filtration. Now, number three is centrifugation. Now, this is applied in the separation of a solid liquid mixture, just like filtration and decantation. Centrifugation also involves a solid liquid mixture in which the solid component is light and therefore suspended in the liquid component. Now, a centrifuge machine is used to spin the suspension placed in a test tube. The spinning forces the suspended particles to settle at the bottom of the test tube with a clear liquid on top of the solid, which can be carefully poured out or decanted. Now, whenever blood is collected in a tube, we'll discover that the blood cells and the plasma are going to just mix together like we have here. All right. Now, to separate the plasma from the blood cells, we'll now make use of a centrifuge machine. Now, the centrifuge machine spins the suspension. All right. Spins the suspension, and then this spinning forces the suspended particles, in this case the blood cells, all right, to settle at the bottom of the test tube with a clear liquid on top of the solid. All right. So in this case, after centrifugation, we discover that the blood cells will now settle at the bottom, and then we are going to have a clear liquid upper layer, which can now be carefully decanted. All right. So centrifugation basically involves a solid liquid mixture, and it is applicable in what? Separation of blood cells from plasma. Now we also have the evaporation to dryness. This is used to separate a solid from its solution. All right. Now, in evaporation to dryness, we no longer have an insoluble solid and liquid. We now have a solid that dissolves in a liquid. All right. That's why we said it is used to separate a solid from its solution. In this case, the solid dissolves in the solution. Now, solution is simply solute plus solvent. Solute is the solid that dissolves in the solution, and then solvent is simply the substance that dissolves the solid or the solute. All right. So in evaporation to dryness, we'll always have a solid dissolving in a solvent giving rise to a solution. And the solid that dissolves is known as the solute. Alright. Remember filtration, insoluble solid in a liquid. Evaporation to dryness, a solute, that's a substance that dissolves, alright, and then a solvent. So yes, it says in evaporation to dryness, the solution is subjected to heat at very high temperature. The solvent escapes into air as vapor. Remember, it's evaporation to dryness. So keep on heating it till all the solvent evaporates. Alright. So the solvent escapes into air as vapor. The solute is left behind and is called the residue or evaporate. This technique is used in salt making industries to separate salt from seawater. So let's say we have a solution like salt water. Salt water. All right. Now, salt water is basically salt and water. This is a mixture of salt and water. All right. Salt dissolves in water. So salt is our solute, and then water is our solvent. To separate this salt from water, we make use of evaporation to dryness. And evaporation to dryness involves heating this mixture here, this solution. We heat it to a point whereby the whole water will evaporate. Of course, we know that water starts evaporating at 100 degrees Celsius. All right. So we are going to heat the mixture or the solution beyond 100 degrees Celsius till all the water will evaporate, and then we are going to be left with what? Just salt. That's what we mean by evaporation to dryness. All right. So evaporation to dryness is applicable wherever we have a solute and a solvent. That's a soluble solid and a liquid. That's when we use evaporation to dryness. Unlike filtration, where we use where we use it anytime we have an insoluble solid and a liquid. Evaporation is for soluble solids and liquid. Now, the next one here is crystallization. This method is used to separate a solid from its saturated solution. In crystallization, we're also going to have a solid that dissolves in a solution, but in this case, a saturated solution. Saturated solution, that's a solution that contains the maximum amount of solute it can dissolve and cannot dissolve any more solute. Alright, so a solution which cannot dissolve any more solute is what we call a saturated solution. Alright, it cannot dissolve any more solute because it has already gotten the maximum amount of solute that it can dissolve. Alright, so crystallization is employed whenever we have a solid and a saturated solution. Now, in crystallization, a hot saturated solution of the solid is cooled in an ice bath. Alright, so crystallization involves cooling. Alright, unlike evaporation to dryness that involves heating it till the solvent evaporates. In crystallization, we have a hot saturated solution being cooled in an ice bath. Now, the crystals of the solid easily separate out and are obtained as residue by filtration. Alright, so during this process of cooling, we are going to have the crystals of the solid being separated out from the mixture. Alright, now this technique is used to separate substances which decompose easily on heating, and also in industries where purity of the product is important. Emphasis on this. Crystallization is employed in industries where purity of the product is what? Important. Example, we have the manufacture of drugs and in sugar production. All right. So crystallization also involves a soluble solid in a liquid. All right. But in this case, it involves cooling a hot saturated solution of the solid. All right. And then during this process of cooling, crystals of the solid will easily separate out from that mixture. Crystallization is employed also for substances that decompose easily on what? Heating. And also, it is a technique that is used when purity is of great importance. Example, in the manufacture of drugs and in sugar production. So that is just the key point about everything you need to know on crystallization. Now the next one is fractional crystallization. Now this is used to separate two or more solid solutes. So for crystallization, you just have just one solid solute. One solid, alright, solute. That's the solid that dissolves in the solvent. Just one. What we are talking about, just separating just one substance, we call it crystallization. Now if we're talking about two or more solid solutes, we use what? Fractional crystallization. Alright. They say which are present in the same solution in roughly equal amounts. Alright. Crystallization, fractional crystallization also involves the same method in as crystallization, that's cooling a hot saturated solution. The only difference is that in fractional crystallization, we're looking at two or more solid solutes, whereas in crystallization, we're looking at just one solid solute. Now, note the solubilities of the two or more solid solutes in the solvent must differ at different temperatures. All right, the solubility must differ at different what temperatures, so that during the cooling process, crystals of the relevant solute will come out of the solution. All right, leaving behind the others which are still within the limits of solubility. So the solubilities of the two or more solids in the solvent must differ at different temperatures, so that as we cool them down, they are going to come out. The crystals of these solutes, all right, or of these substances will come out at different points in time. All right, so that's why this point is very important. The solubilities of the two or more solid solutes in the solvent must differ at different temperatures, so that as we cool them down, all right, let's say we have substance A and substance B, and then we have our liquid or solvent. All right, this is a mixture, for instance. As we cool down this mixture, we cool it, let's say we are cooling it from like a temperature of 95 degrees Celsius. As we cool it down to a temperature of maybe 45 degrees Celsius, crystals of substance A will form, and then we'll separate it from the mixture. We'll cool it down further to maybe 30 degrees Celsius. You see that crystals of substance B will form, and they will separate it from the mixture. All right, so that is what this point here means. The solubilities of the two or more solid solutes in the solvent must differ at different temperatures, so that during the cooling process, crystals of the relevant solute will come out of the solution, leaving behind the others which are still within their limits of solubility. Now, our next point here is distillation. Now, in distillation, it is used to recover a solvent from a solution. So, distillation also involves a solute and a solvent, giving rise to a solution. But in distillation, we use distillation to get the what? Solvents. Alright? Unlike evaporation to dryness, remember this is also similar. We also use evaporation to dryness in a case like this. In evaporation to dryness, we use it to get the solutes, alright, from the solution. That's the difference. Evaporation to dryness is used to get the solute. Like in the case of salt and water, we use it to get salt from water. Salt is a solute. But in distillation, we use it to get the what? Solvent. Distillation is used to get the solvent from the solution. And the solution is heated in a flask to vaporize the solvent. This is what the setup for distillation looks like. Alright. The solvent passes along a condenser which is cooled. Alright. So as we heat up the process, first they say the solution is heated in the flask to vaporize the what? Solvent. So as we heat up the solution, the solvent is going to vaporize, and then the solvent will be passed along a condenser which is cooled. Now this recondenses the vapor into what? A liquid called the distillate, which is then collected in a receiver. So this is what the setup looks like. All right, we have the clamp, and then we have our solution here. Okay, the solution is heated. In this case, we have salt and water. This is also a mixture of salt and water. But the only difference between distillation and evaporation is that in distillation, we want to get the solvent. Evaporation to dryness, we want to get the solute. So this is a solution. It's being heated, and then as we heat it up, the water is going to evaporate, and then it's going to be collected along what? A condenser. Now this condenser is cooled. By cooling it, we convert that vapor to liquid, and then we'll now collect it in a receiver. All right, so this is what the distillation process looks like. Now we also have fractional distillation. The previous one we talked about is simple distillation. This is fractional distillation. Now fractional distillation is used to separate a mixture of two or more miscible liquids into their component parts or fraction. All right, so fractional distillation is for two or more miscible liquids. When we say miscible liquids, that's liquids that can mix with each other. For instance, crude oil. All right, crude oil is a mixture that contains more than two miscible liquids. We have kerosene, petrol, diesel. All of them are found in crude oil. So whenever we have liquids that mix with each other, we use fractional distillation. Now here they said in fractional distillation, the components possess different boiling points. Emphasis on this. All right, the separation is based on difference in what? Boiling points. Now for efficient fractional distillation, the difference in the boiling points between successive fractions must be more than what? 10 degrees Celsius. Crude oil is separated into its components using fractional distillation. The fractional distillation plant is made up of two main parts. We have the boiler where the crude oil is kept boiling and the fractionating tower where the actual separation takes place. Okay, and then the fractions with the lower boiling points will emerge near the top part of the tower, while those with higher boiling points will come out near the lower part of the tower. So we have substances like petrol, which in this case is called the fuel oil, being brought out at very high temperatures of 370 degrees Celsius at the bottom of the tower, and then substances like butane and propane being brought out at very low temperatures, like 20 degrees Celsius and 150 degrees Celsius at the top of the tower. Now the next one we have here is precipitation. Now this is a technique that works based on difference in solubility of a solid in two different miscible liquids. That's where we use the concepts of precipitation. All right, we have a solid in two different what? Miscible liquids. Two miscible liquids. That's where we use precipitation. Now the difference in solubility is used to separate the solid, okay, when it is dissolved in one of them. Difference in solubility in the sense that the solid will be able to dissolve in one of the liquids but not in the other. All right, so this difference in solubility is what is being used to separate the solid. Example, we have iron 2 tetraoxosulfate 6, all right, which is soluble in water but not in ethanol. So this is how precipitation works. Remember, we have a solid and two miscible liquids. Solid, liquid A, and then liquid B. Do not forget, it is stated here that the difference in solubility is used to separate the solid when it is dissolved in one of them. This sentence here simply means this solid can dissolve in liquid A but not in liquid B. Alright, so let's say we have a mixture of solid and liquid A together. Solid and liquid A together. To separate this solid from liquid A, we add liquid B to this. Adding liquid B will now make a precipitate of this solid to be formed. Alright, so this solid will now form a precipitate because it is not soluble in liquid B. So adding liquid B to this mixture will force this solid to form what? A precipitate. Alright, and to separate this, we'll now use the precipitate, we'll now use the method of filtration. If we look into these details of this example here, it says, example, iron 2 tetraoxosulfate 6 is soluble in water but not in ethanol. Now, if ethanol, which is miscible with water, is added to a solution of iron 2 tetraoxosulfate 6 and water, the iron 2 tetraoxosulfate 6 will be precipitated out of the solution and can then be separated by filtration. So it's basically what I've said already. Alright, we have ethanol, we have water, we have iron 2 tetraoxosulfate 6. Alright, now iron 2 tetraoxosulfate 6 can dissolve in water. So let's say we have a solution of iron 2 tetraoxosulfate 6 and water. Now to separate iron 2 tetraoxosulfate 6 from water, we now add ethanol. Ion 2 cannot dissolve in ethanol. Alright? Ion 2 tetrahydrosulfate 6 cannot dissolve in ethanol. So by adding ethanol to that solution of water and ion 2 tetrahydrosulfate 6, we are going to make ion 2 tetrahydrosulfate 6 to form a precipitate. Alright? And then to separate the ion 2 tetrahydrosulfate 6, we'll now use filtration to separate them. So that is the precipitation method of separating mixtures. Now the next one is separating funnel. Now this is used to separate a liquid mixture. Emphasis on this. Separating funnel, liquid mixture. Alright? Though it is different from that of fractional distillation. Fractional distillation also involves liquid mixture. The only difference is that fractional distillation involves two miscible liquids, whereas this separating funnel involves two immiscible liquids. That's liquids that do not mix with each other. Let's go on with this. It says it is used to separate a liquid mixture in which the liquids do not mix together and have different densities. So that's where we use a separating funnel. Anytime we have two immiscible liquids, separating funnel. If they are miscible liquids and we have difference in boiling points, fractional distillation. All right. So example, we have a mixture of petrol and water. A mixture of petrol and water. Petrol and water do not combine together. They do not mix. All right, and they have different density. So we use this what separating funnel. As I said, the components of the mixture will separate into two distinct layers when poured into the funnel. That is separating funnel. The lower layer is a liquid with higher density, while the upper layer is a liquid with what? Lower density. The lower layer is removed through the tap of the funnel, while the upper layer is left in the funnel. So this is separating funnel. Alright. So this is the lower layer, being water. Alright, is going to be separated using the tap, and then this is the upper layer being petrol. Alright, so separating funnel is for two immiscible liquids. That's liquids that do not mix together. Alright, two immiscible liquids. Two immiscible liquids. Alright, so they have different densities. That's why we see them forming layers, petrol layer and water layer. So to separate them, we use the tap and then gently allow the lower layer, all right, to move out, and then leaving the upper layer in the separating funnel. We also have sublimation. Now this is used to separate a solid mixture in which one component can sublime, that's change directly from solid to vapor. Sublimation simply involves a situation whereby a solid changes state from solid states, all right, solid directly to what? Vapor. That is what sublimation is all about. All right, so we said it is used to separate a solid mixture in which one component can sublime, that's changed directly from solid to vapor, while the other components cannot. So whenever we have a substance that can sublime and one that cannot sublime, we use sublimation. Examples of substances that can sublime, we have camphor, we have ammonium chloride, we have iodine. So these substances are also purified industrially by sublimation. Right? Camphor, ammonium chloride, iodine, purified industrially by sublimation. Now we also have the sieving. This is used to separate solid particles of different sizes. Alright, so sieving is for solid particles. When the solid particles have different sizes, the mixture is placed in a sieve with a mesh of a particular size. Alright, particles smaller than the mesh size of the sieve will pass through the sieve, while the bigger particles will remain on the sieve. Example, we have a mixture of gravel and sand. Gravel and sand are both solids. This is a solid mixture, but then gravel is bigger than sand. All right, so we have particles with different sizes, and they will now use a mesh with a particular sand with a mesh. We now use a mesh with a particular size. Particles smaller than the mesh will pass through the sieve. The ones that are bigger than the mesh will not pass through. They'll be trapped in the sieve. So that is the sieving method. Now we also have the chromatography. Now this is used for separating complex mixtures. Alright, that's where we employ chromatography. Example, dyes, alright, is used to separate complex mixtures, or we can say colored pigments. Now, the commonest chromatographic method is the paper chromatography. Now, in this method, a chromatographic paper or filter paper is the stationary phase, all right, while an organic solvent in a closed airtight in a closed airtight tank is the mobile phase. Paper chromatography involves a stationary phase and the mobile phase. All right. In paper chromatography, the filter paper is the stationary phase. The organic solvent is the mobile phase. That's the one that can move. All right. The solution containing the mixture to be separated is spotted on a line. All right. On a line near one end of the chromatographic paper, like we have here. All right. So they said the solution containing the mixture. This is the solution, or this is the dye here. It is spotted on a line, all right, on a line near one end of the chromatographic paper. So this is one end. This is the chromatographic paper, all right. So this is the end we are talking about now, and the paper placed inside the tank. So this is our tank, all right. The paper is placed inside the tank with the spots on the origin above the solvent. These are our solvents. This is spots, all right, near one end of the paper, which is the origin. Okay, it is placed. It is placed. They said near one end of the chromatograph, and the paper placed inside the tank. Okay, with the spot on the origin above the what? Solvent. So now the solvent moves up. That's what we have here in this other diagram. Solvent moves up, that ascends the paper, thereby separating the mixture in the spots into a number of other spots corresponding to the number of components present in the mixture. So as the solvent moves up, it separates the components of this mixture, all right, into their different parts. Okay, so this is what paper chromatography is all about. Okay, so as the solvent moves up, it separates the mixture into its different components. Now the next one is the magnetic separation. Okay, now in magnetic separation, it says if one component of a mixture can be attracted by a magnet, then its removal from the mixture can be effected by the use of what? A magnet. As simple as that. Alright, let's say we have a mixture of iron filings and sand. To separate the iron filings from sand, we make use of what? A magnet. Alright, this is also a solid mixture. Alright, whenever we have a mixture where the components of that mixture is, as the components of that mixture are solids, right, like iron filings and sand. But just that in magnetic separation, one of the components must be affected by what? A magnet. If you have iron filings and sand, iron filings can be attracted by a magnet, sand cannot. Alright, so we use it to separate components that can be attracted by a magnet from components that cannot be attracted by a magnet. Also here it says a mixture of iron filings and sulfur, alright, can be separated by this method. Iron filings can be attracted by a magnet, unlike sulfur. Sulfur cannot be attracted by a magnet. And this method is also used in steel industry to remove magnetic impurities from tin ore. So that is the magnetic separation technique. Now we are going to be looking at some commonly asked exam questions. These are just past exam questions on separation techniques. Now, number one here says the order in which a mixture of sand, ammonium chloride, and sodium chloride can be separated is, we have sand, we have ammonium chloride. Okay, we have sand, we have ammonium chloride, and then sodium chloride. We want to separate this mixture. All right. So now they said first sublimation, dissolution, filtration, and evaporation. So let's look at it together. Sublimation. Is there any substance that can sublime here? Yes, ammonium chloride. All right, it's a substance that can undergo sublimation. Okay, so if we have a mixture of sand, ammonium chloride, and sodium chloride, okay, it makes sense to start with sublimation. Allow the ammonium chloride to sublime, and then dissolution. That's to say, we dissolve the mixture that will be left, sand and sodium chloride, in water. Yes, it makes sense. That's adding water. And then filtration. Filtration Now remember, if we add sand and sodium chloride to water, sodium chloride, which is some salt, will dissolve. Sand will not dissolve. Alright, so we can filter sand, filtration. Yes, it makes sense. Now to get the sodium chloride from water, we'll now use evaporation to dryness. So it makes sense. Option A looks like the correct answer. Now number 2, they say sugar is separated from its impurities by, now remember, crystallization. Alright, is used whenever purity is of essence or is of importance, and crystallization is used in sugar industries and also in drug making. All right, so sugar is separated from its impurity not by distillation, not by evaporation, not by precipitation, but by what? Crystallization. Whatever purity is of great importance, we make use of crystallization. Now number 3 says a mixture of petrol and water, petrol and water, are they miscible liquids? No, they are not. All right, they are not miscible liquids. All right, so whenever we have two immiscible liquids or two liquids that do not mix, don't forget separating funnel is what we use. All right, you can just pause this video and attempt some of these questions before getting to know the answers, and also don't forget to make your notes as you watch the video. Now number 4, it says chlorophyll obtained from green leaves of plants can be shown to composed of more than one colored component by the technique chromatography. Whenever we have colored mixtures, we use chromatography. Now this question says a mixture of sugar and sulfur can be separated by, okay, our first option says A, dissolution in water first. Dissolution in water. Okay, so if we dissolve sugar and sulfur in water, sugar plus sulfur, all right, if we add this, if we add water to this, sugar will dissolve in water, but sulfur will not dissolve in water. Okay, so first sugar dissolves in water, and then it says evaporation. All right, if we have these two together in water, we now use evaporation to dryness. Evaporation to dryness will now remove the water, and then we'll now be left with sugar and sulfur again, which is what we want to separate. No, it does not make sense. And then filtration. It would have just been better we use filtration to separate sugar and sulfur, but filtration cannot work for your sugar and sulfur. So option A is not correct. Option B says filtration first. We're looking at a mixture of sugar and sulfur. We want to start with filtration. No. All right, filtration, don't forget, is applicable whenever we have a soluble, we have an insoluble solid. All right, that's, we have a solid that is not dissolved in a liquid. That's when we use what? Filtration first. In this case, sugar and sulfur, they are two solids. We cannot use filtration. Filtration is only applicable whenever you have a solid, all right, that does not dissolve a liquid. That's an insoluble solid and a liquid. That's when we use filtration. So here we have two solids, not an insoluble solid and a liquid. So filtration cannot work first. Now option C says dissolution in water first. Okay, we dissolve in water and then filtration. Okay, this makes sense. Sugar and sulfur first, all right, in water, that's dissolution. All right, now remember I said sugar will dissolve in water, but sulfur will not dissolve in water. All right, so if we have sugar plus sulfur in water and then filtration, filtration is going to now take out sulfur. All right, so we use filtration to take out sulfur once we have these two dissolved in water. So we'll now be left with sugar in water. So to take sugar out of water, we'll now use evaporation to dryness. So evaporation. So option C is the correct answer here. Option C. Dissolution in water first, then filtration to take out sulfur, and then evaporation to dryness to take out sugar. So option C is the correct answer here. Now number 6 here says, which of the following as an example of a mixture? Which of the following is an example of a mixture? Blood is a mixture, all right, because the components of blood can be separated by physical method, and the physical method is centrifugation. All right, so blood is a mixture. So the next one here is sand. Sand is a single substance, it's not a mixture. Washing soda is a chemical substance. That's a chemical formula or a chemical equation. Common salt too is a single substance. It's also a chemical substance, sodium chloride. Alright, so the only mixture we have here is blood. Now, number 7 here says, which of the following methods can be used to obtain pure water from a mixture of sand, water, and methanoic acid? So we have sand, we have water, we have methanoic acid. Methanoic acid. Alright, so how do we go about this? Okay, first they said neutralization, okay, with sodium hydroxide followed by filtration. Okay, so if we neutralize this solution with sodium hydroxide, this is going to form salt plus water. All right, by neutralization, if we use neutralization here, this is now going to form salt and water. All right, remember we want to obtain, they say which of the following methods can be used to obtain pure water. That's we want to get water. All right, we want to get water from this mixture. So neutralization will get salt and water. They now said followed by filtration. All right, followed by filtration. Filtration is going to take out sand. Okay, and they will now be left with salt and water. We want to get pure water from this mixture. Okay, it does not work. No, it's not going to work. All right, because if we use sodium hydroxide to neutralize this, we get salt and water. All right, we'll now carry out, we're talking about option A. We'll now carry out filtration. We'll take out sand. We'll still be left with water and salt, and we'll still be left with salt and water. So we'll not be able to get pure water. It does not make sense. Option A is not correct. Option B now says neutralization with sodium hydroxide followed by distillation. Okay, it makes sense. This is correct. Okay, let me explain now. Neutralization with sodium hydroxide, okay, is going to convert this to salt and water. And then distillation. Remember, distillation is used whenever we want to get the solvents, okay, from the solution. Solvent from solution, you use distillation. So by distillation, we are going to be able to evaporate water and then trap it into a condenser. All right, trap into condenser. All right, so option B is the correct answer here. Neutralization with sodium hydroxide followed by distillation. Fractional distillation, no, we do not have difference in boiling points here. They say filtration followed by distillation. Filtration followed by distillation, option D. Okay, can we filter out sand from this? Followed by distillation. So if we filter out sand, we'll now be left with water and methanoic acid. Can distillation take out? No, no, no. Methanoic acid can actually combine with this. All right, so we need to neutralize this first to salt and water before uh, distillation. So option B, I still go with option B. All right, so option B is our correct answer here. So our next question here, this is question number 8. Okay, this one says the separation technique that is based on the principle of solubility of a solid in two miscible liquids is, do not forget, this is precipitation. You can go back to the beginning of this video and look at precipitation again. We use precipitation whenever we have a solid, okay, in two miscible solid plus two miscible liquids, where we say the solid is going to dissolve in one of the liquid but not in the other liquid. All right, but then we have the liquids being miscible, that they can easily combine with each other. So we have a solid in two miscible liquids, we make use of precipitation. All right, okay, so you can go back to the beginning of this video and look at precipitation again. So with this, come to the end of this video. Please make sure to drop a comment if you have any question, and also do well to like this video, subscribe to the channel, and share to your friends. I'll see you in the next.